linear motion, two moving objects, C, starting in different places. So in page 32 in our books, we're looking at question 21 as our example. And here we're told that at a certain moment in the Tour de France, Alberto is 22 metres behind Gustav. Alberto is cycling at 12 metres per second, accelerating at 1 metres per second squared. Gustav, who has just fixed a puncture, starts from rest and accelerates with an acceleration of 2 metres per second squared. And we're asked, after how long will Alberto catch up with Gustav? So we're looking for time. And then it says, after how long more will Gustav overtake Alberto again? So when we're looking at this type of question here, if we do a little sketch of what we have two people, Alberto and Gustav, but there's a distance between them to begin with. So we have Alberto and we have Gustav, and then we have the point at which overtaking occurs. But the gap between them to begin with is 22 metres. So we call this gap D. So if we say this is Alberto and this is Gustav, well, if Alberto travels a distance S1 before overtaking occurs, in other words, Alberto catches up with Gustav, and Gustav travels a distance of S2, well then the key to solving this problem is that we can see that S1 must equal D plus S2. Now, of course, you could have called Alberto's distance S2, in which case we would say S2 is equal to D plus S1. So whatever way you label your diagram, you then will write down the relationship. So this is our key. So let's set up our equations. So we're going to say Alberto, and we know that he has an initial velocity of 12 metres per second. We know that he's accelerating at 1 metres per second squared. The time at which overtaking occurs, we're going to say is t, because they're travelling the same length of time. The distance he travels, we're saying, is S1. So therefore we say S is equal to ut plus a half at squared. So in other words, S1 is equal to U times T plus a half times A times T squared. So S1 is equal to 12T plus a half T squared. So that's our first equation. Then we look at Gustav. And we can say that Gustav has an initial velocity of 0. His acceleration is 2 metres per second squared. Time spent travelling is t. And the distance that he travels we're going to call S2. So again, subbing into the same equation, S equals ut plus a half at squared. We're going to have 0 times t plus a half times 2 times t squared. And that gives us S2 is equal to t squared. So we then say, but on overtaking, S1 is equal to D plus S2. So therefore that means that 12t plus a half t squared must equal t squared plus the gap, which is 22 metres. So I'm going to multiply across by 2 there to eliminate my fractions. So we have 24t plus t squared is equal to 2t squared plus 44. So if I bring everything to one side, I'm going to end up with a quadratic equation, t squared minus 24t plus 44 is equal to 0. So factors that multiply to give us 44 and add to give us minus 24 must be minus 22 and minus 2. So we have t squared minus 22t minus 2t plus 44 equals 0. To get the highest common factor, which is t, that leaves me with t minus 22. To get minus 2 as being common, and that leaves me with t minus 22. And again, these two brackets are the same, so to get my highest common factor, I'm left with t minus 22 times t minus 2 equals 0. So that means that if both factors multiply to give us 0, one must be 0, or both must be 0. So then we have 2 times. T1 will be the first one, T2 will be the second one, and our time is in seconds. So what that basically means is that Alberto overtakes Gustav after 2 seconds. And then Gustav overtakes Alberto after 22 seconds, but that would be 20 seconds later. Let's rephrase that. So Gustav overtakes Alberto 20 seconds later. Okay, so this 22 seconds is 22 seconds from the start, but of course 2 seconds have already elapsed on the first overtaking, and then overtaking occurs again. So that would be 20 seconds after the first point of overtaking. So you're going to go to page 32 in your books, and you're going to do question 23. And then we're going to look at our second example today. So C is where we're looking at the greatest lead. So this example is going to come from our handout that I gave you last week, which is Rowan Tree. And here we have a particle starts from a point 0 with an initial velocity of 2 meters per second, travels along a straight line with a constant acceleration of 2 meters per second squared. So we have initial velocity, an acceleration of 2 meters per second squared. 2 seconds later, another particle starts from rest, also at the same point, travels along the same straight line with an acceleration of 6 meters per second squared. How far from O will the second particle overtake the first? So we're looking for when does overtaking occur. And this time we can see that both start in the same place, travel a certain distance, and then overtaking occurs. So unlike the last example where they started in different places, this time we can see when overtaking occurs, S1 will equal S2. But they don't start at the same time, so we have to be careful of that when we're filling it out. The second part of the question then says, we'll find the greatest lead that the first particle has over the second in motion. So if we think about any two objects that are moving, the only time a greatest lead can occur, in other words, this gap here, is if both of these objects are moving with the same speed. So if one is accelerating or travelling faster, at a certain point what happens is when their velocities are the same, then the gap between them won't change. Now obviously that won't last for a very long period of time, but the greatest lead will occur when V1 will equal V2. So that's going to be the key to part 1 and part 2 in our question. Okay, so let's look at the first part 1, and we have particle and another particle. So we're just going to say particle A and particle B. So we're going to set up our equations for particle A. So in particle A, we know its initial velocity is 2 meters per second. We know it has an acceleration of 2 meters per second squared. It starts at a given time, and the distance it travels we're going to call S1. So therefore, if I'm setting up my equation, S equals ut plus a half at squared. Then we can say S1 is equal to ut plus a half at squared. So S1 will equal 2t plus t squared, and I'll call that equation 1. So now when we're looking at particle 2, we have to be very careful because it doesn't start at the same time. We know its initial velocity is 0 because it starts from rest. It's accelerating much faster, hence the overtaking, but it starts 2 seconds later, so we have to say it's t minus 2 for its time, and the distance it travels will be called S2. So again, subbing into S equals ut plus a half at squared, we get S2 is equal to 0 times the time plus a half times a times t squared. So again, be careful here, we're squaring our time. So I suppose actually if I just go back up to that previous line, just so we don't make a mistake here, make sure t is inside the brackets. So 0 times anything is 0, and then we have a half times 6, which is 3, times t minus 2 squared. Well, that's t squared. Multiply them and double it. Square the second. And now multiply out the brackets. Gives us 3t squared minus 12t plus 12. And then that's equation 2. So now we know when overtaking occurs that their distance travelled will be the same. Because they started at the same place. So that gives us 2t plus t squared is equal to 3t squared minus 12t plus 12. Bring everything to one side and simplify. Gives us t squared minus 7t plus 6 equals 0. Once I divide across by 2 there. Factors that multiply to give us 6 and add to give us minus 1 must be minus 6 and minus 1. Subbing back in and factorising gives us t minus 6, minus 1 is common, leaving us with t minus 6. So we have t minus 6 times t minus 1 equals 0. So if both multiply to give 0, we get t is equal to 6 seconds, or t minus 1 is equal to 0, therefore t is equal to 1 second. But it can't be equal to 1 second because particle B starts at t minus 2 seconds. So therefore, if I was to put in 1, I'd end up with negative time. So therefore, it must be t is equal to 6. So basically that means that overtaking occurs after 6 seconds. But it says how far from O. So therefore the distance, well, we can sub back into S1 or S2. It doesn't make a difference. S is equal to S1, which is equal to S2. So therefore I'm going to sub into S1, where we said S1 was 2t plus t squared. So 2 times t plus t squared gives us 12 plus 36, which is 48 meters. So overtaking occurs 48 meters from the start, from O. Okay, so B says, well, what is the greatest lead? So what is that gap? So we said the greatest lead occurs when V1 is equal to 2. So in other words, that point in time where their velocities are the same. So again, if I set up the equation for V for particle A, well, we know that U is equal to 2. We know that A is equal to 2. T we said was T. So therefore V1 will be given by the equation V is equal to U plus AT. So we have 2 plus 2t. If I then look at particle B, we have U is equal to 0, A was 6, and again remembering time was t minus 2. So therefore we say V2 is equal to U plus AT. So in other words, V2 is equal to 6t minus 12. So by equating 1 and 2, we'll be able to find the time when their velocities are equal. Which is 4t is equal to 14, sorry. And therefore t is equal to 3.5 seconds. So in other words, the greatest lead will occur at 3.5 seconds. So now we know the time where the velocities are the same. We need to work out the distances travelled by each at that time. So we'd say S1 at that time is going to be 2 times 3.5 plus 3.5 squared, which gives us a distance of 19.25 metres. So particle A, did I say was particle A? Sorry. So particle A has travelled S1, so that's travelled 19.25 metres. And S2 then has travelled 3 by 3.5 squared minus 12 times 3.5 plus 12. So therefore S2 has travelled a distance of 6.75 metres when their velocities are the same. So therefore we say the greatest lead must be the gap between those two when the velocities are the same, which is 19.25 minus 6.75 metres. So therefore the greatest lead between the two cars is 12.5 metres. So what you're going to do then is question 45 on the sheet.